For our lesson today. So, last class we talked about pixels, hexadecimal, and how we can store colors using hex. Today we are going to be discussing manipulating our images using the values in your pixels. So if I have some set of pixels, I have this 3x3 little grid. Each pixel has its own set of RGB values, which are going to translate to some image. So this set of pixels is going to look like this. It's just kind of a little shape. There's not a whole lot of information you can encode in a 3x3 square. But as you get more and more pixels, you can get more and more high quality pictures. But once we have this information, we have these numbers, we can manipulate them to modify how our image looks. So let's say I have one pixel. I have one purple pixel. It's got a red value of 120, green value of 20, and a blue value of 220. If I push this through a brightness filter, I now have a slightly lighter purple pixel. My red value went from 120 to 170. My green value went from 20 to 70. And my blue value went from 220 to 255. So for red and green, we added 50. But we only added, 35 for the blue value, because 255 is the max possible value for any color. So this little equation, red equaling red plus 50, green equaling green plus 50, and blue equaling blue plus 50, it works, except when our number would exceed 255. So what we need to do is we need to make sure we're getting the minimum between our addition and our maximum possible value. So if our addition would go over the biggest possible value for any one color, we're going to set it to the maximum instead of that addition. Otherwise, we're just going to use the value we get when we do that addition. So 120 plus 50 is 170, which is smaller than 225, so we choose that. 20 plus 50 is 70, also smaller, so we pick that. And 220 plus 50 is 270, which is too big, so we choose 255 instead, so that we don't go out of bounds. So this works for one pixel, and what works for one pixel will work for every pixel within a picture. So if I want to modify my entire image, I can say for every single pixel in my picture, I want to do that process. I want to add 50 to the red, to the green, to the blue, making sure that they don't exceed 255. So every single pixel, I'm going to get the red, add 50, get the green, add 50, get the blue, add 50. Once I've done it for every single pixel, I will have a slightly brighter version of that same image. And I can do the same thing with a darkness filter. If I added 50 to brighten my image, I can subtract 50 to darken my image. But what edge case do we have to be careful of here?
Zero,
because we can't add a negative amount of a color. So we want to do the maximum value between the subtraction and 0, so that in case our number would go below 0, we don't, subtract too far. So we can use this process to, create a slightly brighter or slightly darker picture. Now, that all makes sense in theory. Now let's talk about how to actually write some code to do that. So in order to manipulate an image in our programs, the first thing we need to do is actually get that image into our program. And we can do this using the image function. It's going to be very similar to the square, or not square, the rectangle, circle, line functions we've been working with for graphics. So we need to give the image function the URL of the image we want, and we need to create a variable to save the image into, just like we did with all the other shapes. So our image URL, that's going to be a string. So whatever string we say, so if I click on this, I get to a picture of the Golden Gate Bridge. So when I run this code, that is the URL that is going to be accessed. The image is going to be selected when I create an image variable. So my image is going to equal that picture, and then I'm going to add my image to the canvas. Now, just like with other shapes, like with circles or with rectangles, there are a few different functions we can call on our image. If I want to decide how big the image should be, I can call the set size. If I want to choose where it will go, I can call set position. The parameters for my size are my width and then my height. So how many pixels wide and how many pixels tall I want my picture to be. And my set position is going to be the XY coordinate of the top left corner of the image. Fortunately, that is consistent with rectangles, so at least there's that one piece of consistency. So once we have an image, then we need to grab individual pixels if we're going to do any kind of manipulation on them. So we can grab individual pixels by using the getPixel function on our image. And we need to tell the getPixel function where within the image our pixel is going to be, so which XY coordinate we want to grab. And it will return a list of the R, G, and B values for the pixel. So I can say my variable pix equals my image.getPixel from the coordinate x comma y, and then pix at index 0 is going to be the red value for that pixel, pix at index 1 is the green value, and pix at index 2 is the blue value. The coordinate system for pixels within an image is just the same as any other coordinate within our grid, except that they are local to the image itself. So the top left corner of the image is 0, 0. As we go to the right, our x values increase until we hit the width of the image. As we go down on the image, the y values increase until we hit the height of the image. So the bottom right corner is my image.getWidth, comma, my image.getHeight is the biggest possible x, y value on an image. All right, so now that we can get any pixel, we need to be able to change those pixels so that we are actually manipulating this image. In order to change the color values for a pixel, we need to call the setRed, setGreen, and or setBlue functions. Each of those needs to know which pixel we're interacting with, so which coordinate we are going to be changing at, and then we need a new value for that color channel. So I can set the red value for the pixel at XY to be whatever value I want. I can set the green value for that pixel to be whatever I want, and the same for blue. So if we look at some very general pseudocode for how I can create an image filter, and we'll look at an actual example after this. I can make my filter function. It's going to accept a pixel as a parameter, and we're going to modify the red, green, and blue values of that pixel according to some function. So in our brightness function, or our brightening function, we added 50 to all three of those values. In our darkening function, we might subtract 50 from all of them. And then we're going to return the updated set of values. We're going to return a tuple or a list of the new values. And then the rest of our code, we're going to loop over every single x, y coordinate in the image. So for every single pixel, we want to get that pixel. We want to find what its RGB value is. We want to get a new color for that pixel by calling our filter function. And then we're going to update our image at that coordinate with that new color that we just got. So let's look at an example. So this is the black and white filter. I have gotten an image from the internet. I believe it's a picture of a dog. But if you want to get your own pictures, you can just Google whatever you like. So Google search dog. I can right-click on a picture, copy image address, and within this string, I'm just going to delete the whole thing. I can paste that link, and now that picture of the dog is in my program. I have to wait for this to finish thinking. Should have done this first. So, well, this program is going to turn this picture into a black and white picture. It's going to grayscale it. And I'm so glad that I clicked stop, so it got rid of it as soon as it changed. So let's look at the code, see what it does. So we've got our change picture function. We're going to loop over for x in range image.getWidth, and then for y in range image.getHeight. So we're going to loop over every x value and every y value to get every single pixel. We're going to get that current pixel. We're going to get a new color, which is going to equal our black and white of our pixel. And then we're going to set the red, green, and blue to all have that new color. So let's look at what black and white does. Black and white takes one pixel. It's going to add up the red, green, and blue values for that one pixel. And then it's going to divide by 3. So it's going to average out the total of those, the total of that pixel. It's going to return that color. So we're going to set all 3 channels to be that one value. And when we have the same value in our RG and RB, that creates a shade of gray. So let's look at this code. This is going to use their Golden Gate Bridge picture, which looks pretty nice, especially when it's grayscale. So we can wait for that to finish thinking. And there we go. We have turned that picture into a grayscale version of the same picture. We've averaged out the red, green, and blue for each pixel and set them all to equal that same average value. If we want to look at how the brightness filter looks in actual code, we've got that same set of for loops for x and y, looking at every single pixel. We're going to get that pixel, and then we're going to call our brighten filter function on our pixel. So brighten filter, we're going to get a new red, a new green, and a new blue using that brighten color, which is just going to get the min of our color value plus whatever our brightening factor is. And we're going to get the minimum between that sum and our maximum pixel value, which is still 255. So we're going to brighten each of our 3 values and then return that as a tuple. And out in our original loop, we can set our red equal to the first value, green equal to the second value, blue equal to the third value, because that's how we packed it in up here. So when I run this, still got our Golden Gate Bridge. Our current brightening factor is 30, so it's not going to get a whole lot brighter. So it changed, it's only a little bit brighter. If I change my brightening factor to be 100, for instance, let's see how it looks this time with a much higher brightening factor. There we go. The picture brightened significantly more than when the brightening factor was only 30. Does that all make sense? Any questions on any of that? Cool. All right.